Okay, this is a past paper question. It is Matrices, one from 2017, and it's question 5. It first of all says let n equal this here, and it says find the rational value of p for which this matrix does not have an inverse. It doesn't have an inverse if the determinant equals 0. If the determinant equals something else, then it does have an inverse and all as well. But if the determinant equals 0, then funny things happen. So we need to put the determinant here equal to 0. So that's what I've done here. Multiplying this out, then 0 times this just gives us 0. Remember, it's minus 1, so it's 1 upon 1 plus 2 upon p plus 1. This here gives us 3. Plus 2p plus 2 equals 0. Rearranging that, taking the 5 over the other side, we get p equals minus 2.5. So that's our value for p for which it doesn't have an inverse. Part 2 then says if p equals 3, find the inverse. Very, very straightforward question here. You should be all over a question like this. And with these new calculators, you can check that you've got the right answer as well. So I filled it in here, and I've changed my p then for a 3. Find my matrix of minors. So how do I do that? I cover up this, and I find the determinant effectively of that. So it's 1 times 1, take away 6. So I've changed that then to a minus 5. I do that for all 9 elements, and I end up then with that. Matrix of cofactors is our second step. So I change the sign of this one, this one, this one, and this one. That's what I've done here. Transpose, so I kind of reflect it in that line there. So that 4 goes to there, that 7 for example goes up to here, so we end up with that. And then I need to get myself my determinant. Now you can get it from up here if you think about it, but our determinant then is 11, so the inverse of this particular matrix that I've asked for is 1 over 11 upon this here. So that's the inverse of that one. Okay, it then says hence solve the following system of equations. Again, a very straightforward question here. We should be all over something like this. So what do? We rewrite the system of equations in this form here, in matrix methods, and we want to get the x, y, and the z on its own. How do we do that? We need to multiply this side and this side by the inverse of this matrix. That's what we've done in the previous question. That's why they've said hence. If I multiply this by the inverse, it just gives me x, y, z. I would recommend checking that out to make sure that you do have the right answer there. It's a good way of checking. So that should give us x, y, z. Then we're doing this times this, so this then times the inverse. If I multiply this row by this, I get minus 44. If I multiply this row by this, I get 55. If I multiply this row by this, it all cancels out and only gives 0. Dividing everything by 11 gives us the 3 values that we need. We get x is minus 4, y is 5, and z is 0.